Here we have the second video for section 3.3, and picking up where we left off, we are on example number 9. Number 9, we have to do 1 minus the cotangent squared of v over 1 plus cotangent squared of v plus 1 better equal 2 sine squared of v. And then if we look at the identities, 1 plus cotangent squared of v is an identity, and in fact it is the cosecant squared of v. And then what we can do is we can take this fraction apart. For example, we can give the 1 over cosecant squared of v, and we can give the cotangent squared of v over cosecant squared. We're just giving the denominator to both parts. One over cosecant squared of v is equal to sine squared of v minus, okay, now here we need to do some splitting of this. Cotangent squared of v is cosine squared of v over sine squared of v, and cosecant squared of v is 1 over sine squared of v, and we can see that those will cancel each other out, and so we get sine squared of v minus cosine squared of v. Now this is very similar to the Pythagorean identity, but it doesn't quite work. And what we look at is, if there would be some way to change this to a positive sine squared v, then we would have it made. And so what we can do here is we can, oh, I'm forgetting the 1 at all times. So plus 1, plus 1, plus 1, and plus 1. And so if we do just a little bit of a manipulation of this, we get cosine squared of v minus, okay, cosine squared of v. If we solve for cosine squared of v, that becomes 1 minus sine squared of v. And then just distributing this minus sign, we get sine squared of v minus 1 plus sine squared of v plus 1 equals 2 sine squared of v. Example number 10, we have sine cubed of theta minus cosine cubed of theta all over sine of theta minus cosine of theta, and that has to equal 1 plus sine theta cosine theta. Well, here we have no identities having to do with cubes, so that probably is going to mean an algebraic factoring. And if we go back, this is equivalent, or basically x cubed minus y cubed. And so how we factor this would be the sine of theta minus the cosine of theta times sine squared of theta plus sine theta cosine theta plus cosine squared of theta all over sine of theta minus cosine of theta. Now it's pretty simple to realize that right here we'll cancel with this. So doing the simplification, we get sine squared of theta plus sine of theta cosine of theta plus cosine squared of theta. If we look, sine squared of theta plus cosine squared of theta, the Pythagorean identity says that equals 1. So this becomes 1 plus the sine of theta cosine of theta, which is exactly what we wanted to prove. Example number 11. The natural log of the cotangent of u equals the natural log of the cosine of u minus the natural log of the sine of u. Now here, the right-hand side is actually more complicated, so that's where we're going to start. And we have to realize that the natural log minus the natural log, using the laws of logarithms, we can rewrite that as the natural log of the absolute value of cosine of u over sine of u. Because the minus here says we can take these and divide the arguments here. But of course, cosine of u over sine of u is equal to the cotangent of u. And so, final answer is the natural log of the absolute value of the cotangent of u, which is exactly the left-hand side. So we have proven what we needed to prove. Number 12, 1 plus cosecant x over the secant x has to equal cosine x plus cotangent x. Well, if this were a cosine here, then I would suggest changing everything in terms of sines and cosines, but that's not the case. So instead I look at this and say, okay, I only have one factor in the denominator, so I'm going to give this to each and every part of the numerator. So we get 1 over the secant of x plus the cosecant of x over secant of x. Now 1 over secant of x is equal to the cosine of x, but so we've got that part. Plus, well, somehow this needs to equal cotangent of x. Well, how can we prove that? We can't just say, oh, it does, so I'm done. Instead, what I have to do is I have to say, okay, cosecant of x I know is 1 over the sine of x. Secant of x is 1 over the cosine of x. And so this will become the cosine of x plus, okay, simplifying this becomes the cosine of x over the sine of x. And of course, the cosine of x over sine of x is equal to the cotangent of x, which is exactly what we needed to prove, so we're ready to go on. Example number 13. Cotangent squared of x plus cosecant squared of x equals 2 cosecant squared of x minus 1. Now in my opinion this is a little more difficult, but at the same time it's the easiest one to deal with. And what I'm going to do is I'm going to take the Pythagorean identity of this. But unfortunately we really don't have a direct relationship to cotangent squared. We know cotangent squared plus 1 equals cosecant squared. So solving for cotangent squared, we would get this to be cosecant squared of x minus 1 plus cosecant squared of x, which adding like terms from this point forward, and we have proven exactly what we needed to prove. Number 14. 1 minus sine t over cosine t equals cosine t over 1 plus sine t. Now my first inclination here would be, okay, my right hand, they are both equally difficult in my mind. So, and they're both in sines and cosines, so changing them isn't going to do any good. So my next inclination would be doing one of those weird things. What do I want to do to change it around? And so I'd look, okay, I've got a cosine t here, and somehow I need to change it to 1 plus sine t. So maybe, I'll try and multiply this by 1 plus sine t. But to keep it equal, I'm going to have to do it up here as well. And notice what happens when we do that 1 plus sine t. We're going to have the difference of squares. So what I'm going to do is I'm going to multiply both the numerator and denominator by 1 plus sine t. Let's see what we get. 1 minus sine t times 1 plus sine t is 1 minus sine squared t. And down here we get cosine of t times 1 plus sine t. Now there is a reason why I wanted to deal with that, or keep it factored, because 1 minus sine squared t. Well, let's see what we've got. 1 minus sine squared t, if we just manipulate the Pythagorean identity, that equals cosine squared of t. And look what happens. This cosine of t will cancel with one of those factors up there, leaving the cosine of t over 1 plus sine t.